Minasan, konnichiwa, Zamurai Engineer desu. In this second module of chapter 5, wherein we have been discussing analysis and use of cost, behavior, we'll now tackle the use of scattergraph plot, that is to diagnose cost behavior. So the scattergraph method. So what is the scattergraph? Scattergraph is a type of graph, as you can see on the figure, the diagram. So there are green points which are scattered throughout the relevant domain. Okay, so that is the diagram for patient days versus maintenance cost in terms of dollars. So as an example, plotting the data points in a graph, total cost versus activity. Almost scattered in some ways. However, we can still give meaning to this. So draw a line through the data points with about an equal number of points above and below the line. That is how we have to estimate the line that would represent all of this scattered data. So by drawing a line, which is on your screen, that is colored red. So the red line is drawn as a straight line with estimated equal number of points, scattered points, above it and below it. Use data point. Use one data point to estimate the total level of activity and the total cost. So we have here in your screen intercept. This is the same meaning as we learned from our algebra equation of a line. We have the y-intercept. In this case, we are talking of intercept, which is the fixed cost, as we already discussed about fixed and variable cost in last module. So fixed cost is equal to 10,000. That is the y-intercept in this diagram. And we have what? A point from the scattered group. We choose, for example, 1 or 2 points in order to define this patient days and total maintenance cost. For example, the first point, the first green point here. If you draw a line vertical, that would correspond to about 800 patients, because this one meaning 1,000, this two meaning 2,000. So less than 1,000, therefore it is about 800, because it is more than half, more than 500, so about 800. And if you draw a horizontal line, so it may easily be observed that it is more than 10,000, but less than 20,000, and less than 15,000, which is halfway between 10 to 20. So it is estimated as 11,000 in this example. So we have to use this data point to estimate the total level of activity and the total cost. Okay, so with intercept and this single point, we can now be able to define the function, the equation of the line, the equation of the red line. Okay. Make a quick estimate of variable cost per unit and determine the cost equation. So variable cost per unit is easily derived from, for example, we have that 1 point, which is equivalent to 800 patient, which corresponds to $11,000. Our fixed cost is, as we saw in the diagram, that is 10,000. So 11,000 minus 10,000, we have an estimated total variable cost for 800 patients, which is 1,000. So 1,000 per every 800 patients. That is our variable cost. Okay. So we can even divide that. Okay. So 1,000 divided by 800. So cancel. So 10 over 8. So that is 5 over 4. And that is 5 over 4 is 1.25. Okay. So $1.25 per patient. That is our variable cost per unit. 1.25 per patient. Okay, so if you have any question, clarification, you want to add to the discussion, explanation, or you have something in mind that you would like to comment on, so please use our comment section below. We'll try to get back on you. Again, this is Dr. EYPEI, preaching engineering for nation building.